We are going to study how to measure things in chemistry and then to use those measurements to do calculations, which will be useful to us when doing experiments. Now, before we get into those measurements, it's important to have a discussion about units, which without the units, every measurement will be totally meaningless. Now, we all understand what a unit is. For example, what units do we usually use to measure length? And most of you would answer centimeters, perhaps meters, perhaps kilometers, maybe miles if you're thinking about states. And these are all units that we use to measure length. There is one unit, meters, which we refer to as the base unit. What we mean by that is it is the basic or the smallest of the units which all other units are related to. For example, we know that a centimeter is 1/100th of a meter and a kilometer is 1,000 meters. So centimeters and kilometers both build upon the idea of a meter, and so we say the meter is a base unit because it is the original thing, the original quantity, the original size that we use to measure a length. Okay? Now, scientists around the world communicate with each other about their findings because that is how we grow that's how we grow in science as the world, as human beings. So it's important for us to communicate, which means that we have to communicate using the same language. There's a lot of units we use to measure length, but when we publish a paper, when we communicate with the scientific community at large, we always use a particular unit so as not to confuse each other, and so we don't have to convert stuff when we are reading each other's papers. And this system of units that are internationally agreed upon are called the SI units, which stands for this fancy term in French, which I will not attempt to say. So for length, the written unit, or the standard international unit, is the meter. Spell it with an R-E because we are Canadian. And the symbol is M. For mass, the international unit is actually kilograms. Okay, it's actually kilograms. But for chemistry, we use grams because it's kind of ridiculous to talk about small things in a large enough quantity as the kilogram. So for chemistry only, the standard unit for mass is grams, symbol G. For everything else, it's kilograms. And you might have come across that in physics where everything is dealt in kilograms. For time, it is the second. That is the smallest base unit for that. The amount of substance, which you will learn about in Unit 5, is called a mole. The symbol for that is MOL. And for volume, the internationally accepted unit is liters, capital L. These SI units you need to know and memorize. It's important to know what the standard unit is when you're reporting your measurements. This box here are just a few units to describe pressure and temperature, which we will be coming across in Unit 6. Don't worry about these and don't memorize these. I give them to you now just so that you are familiar with these, and when you see something like PA or MMHG, you don't freak out and think, what the hell is that? So that box is just for your information. Okay? So there you have it, units. The next section deals with unit conversions. Now that we know what the SI units are, if we are presented with a unit that is not in standard unit, how do we convert one from the other? In chemistry, we have a particular style of writing out our calculations, and it's a particular style that I want you to be familiar with and to be always using when you're doing an assignment or a test. Okay? There's a reason for that, which I'll get into later. When we convert one unit to the next in chemistry, we use what we call a conversion factor. Conversion factor, which is basically something that relates one unit to another. For example, let's just do a very, very simple example, something that you can do in your head right away. How many minutes are there in 3,480 seconds? You might be saying, wow, this is really easy, Ms. Gu. Why are you asking me this question? Because it's to illustrate how to properly set up your calculations and show your work on a test in chemistry class. In chemistry class, we will always start with what we know, or what we're given, or what we're trying to convert. In this case, it is the 3,480 seconds. We write the seconds down. Then we apply the conversion factor. Now, conversion factor is in the form of a fraction, and it converts the unit, and at the same time, it relates the unit to the one you want. In this case, the relationship we want to look at is minutes and seconds. What is the relationship between a minute and a second? Well, in 1 minute, there are 60 seconds. When we look at this question here, we want to convert our seconds into minutes, so we put that on top so that when we evaluate this question, our minutes remains on the top in the numerator, so our final unit will be minutes. We put the seconds on the bottom here, so then we multiply 3,480 by this fraction. The 2 seconds units will cancel, thus leaving us with an answer with just the unit of minutes. Once we figure out how to set that up, we fill in the fraction with the correct relationship. What is the relationship between minutes and seconds? Inside 1 minute, there are 60 seconds. And that is how we evaluate that. In your calculator, you will be punching in your number, 3,180. Then you'll be punching in the division sign, and then you will punch in 60. When you multiply by a fraction, where the numerator is 1 and the denominator is a number, same thing as saying divided by the denominator. Okay? If you feel uncomfortable, you're always free to go punch in 3480 times 1 divide 60. But that's a roundabout way of doing it, and everybody wants to do things fast, right? So, let's get out our calculator. Punch that in there, 3480 divided by 60, and we get 58 minutes. Here's our next question. If a car can go 80 kilometers in 1 hour, how far can a car go in 8.5 hours? Once again, we start with what we know, which is going to be 8.5 hours. We're going to pick our conversion. Now, the question's asking me for distance, and I want to get rid of the hours. And right here, I see that they actually gave me the conversion factor. So, I want my final answer to be in kilometers for distance. I want to cancel out my hours, which is what I start with. What is the relationship between kilometers and hours for this question? This question clearly states that in 80 kilometers, how far we travel in 1 hour is 80 kilometers, so we plot those numbers in. We see that our units for hours cancel, and we are left with the final answer of kilometers. Punch that in, we get 680 kilometers. In your calculator, you would have punched in 8.5, multiplication button, times 80, because you're just multiplying this by a fraction, which the denominator is 1, so it's just 8.5 times 80. And there you have it. Units and how to convert between units. Go out.